appreciate the opportunity to be here this morning. I was here last year to promote an initiative that we had started the year before called It Just Happens. And the whole idea of the program was to challenge all of our traditional processes, practices, and technologies to identify ways that we could delete equipment that wasn't needed, or delete steps that were not needed, or simplify processes, with the idea that things just happened. You didn't have to do anything. Didn't require a lot of human intervention. And so we've been promoting that for the past couple of years. Many of the suppliers out here have come to our campus to talk about It Just Happened ideas. But we felt we needed something new, something that wouldn't replace It Just Happens, but expands it and extends it. And so our new program is Think Differently. So much of what has come out of the It Just Happens occurred because everyone, folks on our team as well as all of the suppliers that supported us, thought differently about how to do things. And so this is our new mantra. So we've told all of our folks in our group, we have to think about everything we do differently. Even proven processes that we've had around for a while, it's no longer sufficient just to solve a problem. We actually have to solve the problem and do it in the most efficient way possible. So this is a slide that I showed last year, and this diagram just points out there's a series of things that we do in the design of a facility. And invariably, for the automation engineers on a project, make all that progress, and then a process engineer or machinery engineer makes one little change, and we have to go back to the beginning and redo many of the drawings. And this doesn't just happen one time, it happens over and over and over again. Right up until startup, we're making changes. And so we were seeing, the historical problems with a number of dependencies and other participants on a project. We've got design input being provided throughout the life cycle, and then it's resulted in the constant change. And some of the new things that I mentioned is that the projects are getting larger and more complex. We've got multiple EPCs, multiple suppliers from around the globe. We've got parallel activities because we want to compress schedule but one thing that's, I'm not sure is new, but it continues to be an issue, is that our project costs are going up, and now our returns are lower. So the number of projects that my company has had today in terms of opportunities are really no different than they were 10 years ago. We have the same portfolio of, at least in terms of the number of projects, but the problem today is that we can't make them economic. And so we've got to come up with a different approach. And so again, we're challenging everything that we do, and we have to think differently about everything. So here's some new characteristics that we're trying to adopt. So reduce customization. We're all engineers, and we're very good at solving problems, and we'll work it until we've solved every possible problem. But what has historically resulted in is a very customized solution. So I went to a Rockwell facility this past summer. It was the low voltage MCC factory, and they showed me their manufacturing process, which seemed very, very efficient. And then there's this group of engineers that were off to the side, and I said, well, what is that group for? And they told us that was their engineered to order group. And I said, well, what is that? Well, we have our standard product that we mass produce, but we get specifications from clients, and it requires changes that are different from our standard solution. So those orders have to go into this engineering group. They then have to develop a design, take the standard product, modify it, and then they proceed with the process. And I said, well, what percentage of the orders go through this group? And they were saying it was 60 to 70%. And so, and I know we fall into that category of engineered to order. And so my message to Rockwell at the time was, we want to get out of the engineer to order. We don't want any of our orders going through that group anymore. We want them to go directly to the manufacturing process. And so there's a bunch of unintended consequences every time we customize something. Now, number one, we've got to create a very detailed specification, so we want to be clear about what we want. The suppliers then have to see that specification, compare it to their standard offerings, identify gaps, and then they have to come talk to us, and we have to have a debate about what's going to be incorporated, what's not going to be incorporated. Okay, then we get agreement there, and then they have to develop a design. And then they have to submit drawings to us for us to review and approve. And then they go into the manufacturing. And then they assemble the gear. And then they do their own internal test to make sure everything works properly. And then we come in and they do the test all over again. And then the gear is then tested, it's disassembled, sent out to the site, installed. We test it all over again. And then we go on commissioning and startup. What we want to do is to eliminate all that, or much of it. We want to order standard solutions such that there isn't a need to have this discussion about what we want. It's already pre-established what we're going to buy. There's no need for a lot of the drawing reviews because it's a standard product. There's no need for us to approve drawings because we already agree on what we're going to get. They'll do their own internal testing, but there's no need for us to do an FAT. So we eliminate a significant amount of steps in the process. Next one, we need to reduce complexity and simplify designs. Historically, the way we've been solving problems is we bolt something else on. We found another problem, we solve it, bolt something else on. And we keep doing that until we get these extremely complex systems that are expensive to deliver and expensive to support. We need to continue to eliminate, simplify, and automate processes. We need to reduce the number of dependencies. Things like Smart I/O has allowed us to do that. We don't really care what's connected to that I/O. We can, at least at the time that we order the equipment. We need to be able to automatically either reduce the amount or automatically generate documentation. This is one of the areas where we spend a lot of money, the suppliers spend a lot of time, is getting all of this customized documentation that we require. We got to take managed risks. So I've told our group that we can't continue working till we get a 100% solution. It has to be something else, an 80% solution, a 90% solution. We can't continue working on things until we get the 100% solution. And then we've got to develop and enable trust with our suppliers. As I just mentioned about FATs, there shouldn't be a need for them to do it once and then us to do it to witness it again. That's repetitive and it's unnecessary. Either we eliminate it completely or we do it at the same time. So there's a number of technologies that the suppliers are developing for us right now, and we have to qualify those technologies. But the suppliers also have to have them tested first. If the product has to be certified, they have their own internal test to make sure that it's a product that they can sell. And then we come in and do a witness test. And usually it's something that's different. And so I've said, we've got to quit doing that. It's repetitive, it's redundant, and it's unnecessary. So let's understand what you have to do for certification and understand what you have to do for internal approval. And then we'll modify that if we need to, and we'll do it one time so that we don't have to do it twice or three times. So here's the list of technologies that we're progressing today. Smart Configurable I/O is a product that's now commercialized from a number of suppliers, and the rest are coming out with it quickly. Virtualization has become something that a lot of folks are doing. Diced is this technology that will allow systems to automatically commission. So you plug in a device, the control system sees the digital tags, they know what it is, they may have data that needs to be downloaded to it, it's automatically downloaded, it commissions the loop. If it's a valve, it can actually stroke the valve automatically so there's no human intervention. The next one is a significant savings, and what we learned is this product actually existed long before we were asking for it. So directly programming the logic solver of the safety system with cause and effects. The product had been out for many years and people weren't buying it. And so this is a significant savings to us. I mean, traditionally what we had to do is every loop was programmed one by one by one. And then we tested it one by one by one because some human actually did the programming. So now it's automatic. We use the master drawing, so there's no need for validation. So that's going to be a significant improvement when we roll that out. Seamless integration between automation and electrical, and we've done some things there where things like load shedding system is no longer a dedicated system. It's part of the process control system. This is the next one that came out as an evolution of Smart I/O. The way the electrical guys did control for motors, it was all hardwired. So you have a stop-start station, HOA station out in the field. It's hardwired to the MCC. A lot of wiring. Why are we doing that? Let's just connect it to Smart I/O, have Smart I/O as part of a lineup in a low-voltage MCC, such that the only thing we connect to that low-voltage MCC are 2 redundant fiber. That's all we have to do for control and monitoring. We eliminate all that hard wiring. And then one of the guys in our group says, okay, you can do that for low voltage, let's do it for medium voltage. Let's continue to do this idea to eliminate much of the hard wiring that we're putting in the field. And then somebody said when we connected all of this MCC or motor control wiring, it increased the number of I/O going into our process control system significantly. And so somebody came up with an idea in our group was, let's convert all of those discrete signals, the 5 for HOA, stop-start, into a single analog signal. So 4 milliamps is start, 7 milliamps is stop. You can do the handoff automatic. Do it all of it with a single analog I/O. Make it HART compatible, such that now we can use dice. Now we can commission all of those signals that before we had to do it loop by loop by loop. Of course, wireless, and then now we're trying to use DC a lot more to eliminate much of the inverters. So here, there's a few new challenges that we're imposing on or asking our suppliers to think about. Control system age in place. You know, historically, what we do is every 10 years or so, the platform changes, and there's an expectation that we have to change out the control system, and we have to completely rip and replace. We can't do that any longer. What it forces us to do is to not make any change because we don't want to incur the cost or the disruption. And so we try to keep these antiquated systems installed in the field for as long as we can. So it could be 10 years, 20 years, 30 years, or 40 years. We want to keep that stuff in there. But then we don't gain all the benefit of all the new technology. So what we're asking our suppliers to do today is we've got to change that practice. What we need is all of the components need to be integrated, but not so tightly integrated such that when we replace one little component, we got to worry about all the impacts to all the other components in the field. We need to be able to replace pieces at a time such that we can always keep it up to date. So if the I/O changes, input cards, we should be able to change that without impacting everything else. Same thing for controllers, servers, everything else. We need to be able to replace it piece by piece. Secure by design. The approach that the industry's taking today is just not sustainable. Adding firewalls, rings of protection, adding virus protection. Number one, it's reactive. It's not, we're not trying to anticipate and do things. It's reactive. And then I've made a joke that in about 10 years from now, we're going to have the most sophisticated security system that does a little bit of process control, because that's going to be the ratio of the hardware. We're going to have all this hardware just for cybersecurity, and it's only going to do a little bit of process control. So we've got to stop that. We need a different solution. Alarms configured properly from the creation. The whole issue of alarm management started from decades ago, where we had existing facilities that had alarm floods. And so we came up with solutions to address that problem. And then when we had greenfield projects, we used the same processes. So what we did is that the design of the facility progressed. The process guys, the loss prevention guys, the machinery guys, the mechanical guys, even the electrical guys added the alarms like they normally do. And then the automation guys for the next year or 2 or 6 months into operations are managing it with alarm management using the tools that we had for brownfield sites. Why are we doing that? That's wasteful. We're creating the problem and then spending years literally to solve it. We ought to be doing the proper rationalization, coming up with templates and tools such that when we establish the alarms, we get it right the first time, such that when the design of the facility is finished, we don't have an alarm flood problem. We don't have to do alarm management. It's no longer an issue. Graphics development. We spend a significant amount of time on graphics development. And literally the way we do it is that we have an operator, not always the one that's going to be at the desk at the terminal when we're operating, but somebody from operations, and they work with the automation provider, and they develop these customized graphics one by one by one. We had a project recently we had 1,400 graphics for that facility. And somebody asked, well, how long did it take for them to create those 1,400 graphics? I said, I don't have a clue, but I can tell you it was way, way too much time. We've got to come up with a better solution to develop graphics for our facilities. And I'll finish with one more slide. And this slide is, somebody sent this to me a few weeks ago, and I said, this is perfect. So this is an Einstein quote. We cannot solve our problems with the same thinking we used when we created them. So we've got to think differently about how we design our facilities and how we operate our facilities, how we maintain our facilities. We can't use the same thinking that we used at the time that these problems were originally created. We've got to think differently. So thank you.